Welcome to our discussion on a topic that often sparks intense debate: nuclear power. This video, titled Nuclear Power, the Overlooked Ally in the Fight Against Climate Change, is designed to explore striking reasons why nuclear energy, despite its controversy, could be an invaluable weapon in the world's fight against climate change. Through delving into its history, understanding the science behind it, and addressing critical safety concerns, we hope to shed light on this often misunderstood energy source. So let's dive right into the facts about nuclear power and its potential as a solution to reducing carbon emissions. Join us as we navigate through this enlightening journey. 1. The rise of nuclear power. A brief history. Nuclear power has had its share of ups and downs since its inception. The idea of harnessing the energy from atoms dates back to the early 20th century. It wasn't until 1954, however, that the world's first nuclear power plant, the Obninsk nuclear power plant in Russia, began its operations. These plants were initially hailed as revolutionary energy sources, capable of providing electricity without the burden of carbon emissions. As the technology evolved, countries around the globe started building their own nuclear reactors. By the 1970s, nuclear power was considered a key player in the energy mix, promising a bright, cleaner future. Unfortunately, incidents like the Chernobyl disaster in 1986 and the Fukushima Daiichi nuclear disaster in 2011 cast a shadow over this potential, raising safety and environmental concerns. Yet despite these setbacks, more recent advancements and stringent safety measures have reignited discussions around nuclear energy. It positioned it once again as a viable option in the push to curb climate change. 2. How nuclear power works. The science behind the energy at its core, nuclear power is derived from the process of nuclear fission. This is where atoms, typically of uranium or plutonium, are split apart to release energy. When these atoms are split, they release not only massive amounts of heat, but also neutrons, which then collide with other atoms, sustaining a chain reaction. This is similar to a domino effect, where one event triggers another in a continuous cycle. The heat generated during this process is used to produce steam, which in turn drives turbines to generate electricity. What's remarkable is the efficiency of nuclear power. A single uranium pellet, roughly the size of a fingertip, can produce the same amount of energy as a ton of coal or 150 gallons of oil. This illustrates the immense potential of nuclear energy, making it a powerful ally in the realm of clean energy. The nature of this energy production ensures minimal carbon emissions, making nuclear power a promising candidate for reducing our carbon footprint. However, the challenge lies in safely managing the radioactive waste that is produced as a byproduct of this process. 3. Safety concerns. Addressing the elephant in the room. Safety remains one of the most debated issues when it comes to nuclear power. The catastrophic events of Chernobyl and Fukushima continue to echo in discussions, serving as stark reminders of what can go wrong. While these disasters have indeed left scars, it's crucial to recognize the strides made in technology and safety measures since then. Modern nuclear reactors are equipped with advanced safety features designed to prevent similar catastrophes from occurring in the future. Redundancies, fail-safes, and more robust systems ensure that the risks are minimized. It's akin to an airplane, where multiple systems and protocols are in place to handle every conceivable malfunction, ensuring safe air travel. The aim now is to strike a balance between harnessing the power of the atom and ensuring public safety. Public perception plays a significant role in this regard, requiring continuous efforts to educate and inform communities about the measures ensuring their safety. 4. Nuclear waste, manageable or a ticking time bomb. A considerable challenge with nuclear power lies in managing its waste. One of the main products of nuclear reactions is radioactive waste, which can remain hazardous for thousands of years. The dilemma of storing this waste safely is often described as a ticking time bomb. Presently, waste is stored in specially designed facilities known as deep geological repositories. These repositories are like fortified bunkers, engineered to keep the waste isolated from the environment. Such facilities are underground, providing additional layers of protection. The idea is to isolate waste from the biosphere until its radioactivity diminishes to safe levels. Continual efforts in research focus on improving waste management through recycling the waste into fuel or developing longer-term storage solutions. As technology advances, the hope is to find more sustainable options to deal with nuclear waste effectively. 5. Environmental impact, a solution to carbon emissions. One of the most compelling arguments in favor of nuclear power is its minimal carbon footprint. Unlike fossil fuels, nuclear plants do not release carbon dioxide during electricity production. In a world grappling with climate change, the absence of emissions makes nuclear energy a potent tool in reducing global carbon levels. A common analogy portrays nuclear plants as electric cars of the energy world, effective and emission-free. However, while nuclear itself is clean, the entire cycle is not free from environmental concerns. Mining for uranium, plant construction, and decommissioning can have negative environmental impacts. Despite this, when the complete life cycle is considered, nuclear power still maintains one of the lowest carbon footprints, making it an attractive option in the fight against global warming. The challenge is to maximize the benefits while mitigating the ancillary environmental impacts associated with nuclear energy. 6. Economic viability, the cost of clean energy. On the surface, nuclear power appears to be an expensive venture due to high startup costs. Building a nuclear power plant requires substantial investment in technology, infrastructure, and safety measures. However, once operational, the costs of fuel and maintenance are relatively low, making nuclear an economically competitive source of power. Think of it as analogous to buying a high-end electric vehicle. It might be pricey up front, but the recurring costs are substantially lower compared to traditional options. Over time, as operational expenses decrease, nuclear power could produce electricity at a cost similar to or even lower than that of fossil fuels. This economic advantage gains traction, especially as carbon pricing or taxes on fossil fuels becomes more prevalent in global markets. When weighing short-term costs against long-term benefits, nuclear power offers a promising blueprint for sustainable energy that harmonizes safety, environmental benefits, and economic viability. 7. The global perspective. Countries embracing nuclear power. Worldwide, a new chapter for nuclear power seems to be unfolding. Countries like France, China, and Russia continue to expand their nuclear capabilities, positioning themselves as frontrunners in leveraging this energy source. For instance, France derives over 70% of its electricity from nuclear power, showcasing its commitment to a cleaner and more sustainable energy future. China, with its burgeoning population and rapid industrialization, is also making vast investments in nuclear technology. They are building new plants and innovating in reactor designs. These efforts symbolize a broader global acknowledgement of nuclear power as a necessary ally in the battle against climate change. Nations are increasingly collaborating on research and development, sharing knowledge to fortify the nuclear landscape. This cooperative approach reinforces the potential of nuclear energy as a unifying strategy in our collective quest for sustainable energy solutions. 8. Nuclear power in the future, navigating forward. The journey of nuclear energy is far from over. Its future, while uncertain, promises to play an integral role in the global energy landscape. Innovations such as small modular reactors are poised to enhance safety and efficiency, potentially revolutionizing how nuclear power is utilized. These reactors are a fascinating prospect, much like turning a bulky mainframe computer into a sleek laptop. Efforts in research and development are paving the way for breakthrough technologies and solutions that could redefine the nuclear narrative. As countries continue to invest and innovate, nuclear power may very well cement its place as a cornerstone in achieving a sustainable, low-carbon future. Understanding and addressing safety concerns, effective waste management, and economic factors will be crucial as nuclear power is poised to become an indispensable ally in combating climate change.